All right, we're going to graph a couple rational functions. We got x squared minus 4 over 3x for the first one. That factored to x minus 2 times x plus 2 over 3x. So hopefully right away you can say, well, we know that there is a vertical asymptote at x equals 0, which is kind of annoying a little bit because the mark is kind of a pain. So there it is though, and I'll use a different color. And then it said, we know our zeros would be 2 and negative 2. So those are our zeros, and I'm going to use a different pen here, try it again. So 2 and negative 2. Those are our zeros. Now, we're going to have to make a sign table. We're going to use the three numbers. 0, 2, and negative 2 are our numbers. And in my sign table, I'm going to use x minus 2, and x plus 2. The 3 doesn't matter. 3 is a positive factor. It doesn't change sign. So if I take this table, I blow up. This is what I got for a table. And I did my sign table, again, checking here, all the way across, up and down. So just to talk about the x, obviously x is negative in here, negative between negative 2 and 0, positive here, positive here. And again, we have experience with sign tables. So now I have to decide. So I know it's negative, and I know there's no horizontal asymptote. Let me actually back up for a second. The one thing we should realize, there's no y-intercept, and there's no horizontal asymptote because the highest power and the top and bottom do not match. In fact, the top power is bigger, so it runs away to infinity. I know this is going to look something like this at those extremes this time. So now I just got to fill in the table. So it's negative out here. In between it's positive. In between it's negative, and in between it's positive. So if I graph this with purple, I'm going to cheat a little. It goes to the asymptote, and it looks like that. Comes from the asymptotes, and it probably looks like that. And I can leave the gold up there, but that is the graph. No holes, all right? The domain, if we want to put the domain up here, domain is all reals. X can't equal 0. The range of this thing, it's all reals. You're right, negative, positive is the range. So there's no holes, it has everything. So the range of this is all real. No y-intercept. We know the x-intercepts are 2 and negative 2. All right. On the next one, all right, we agree that this factors, and I'm going to do this one all the way out. This one's much more complicated. I'll start that it factors into that. Negative x minus 3 times x minus 4 over x minus 2 times x plus 2. So it has asymptotes at 2 and negative 2 this time. All right? 2 and negative 2 are the asymptotes. So right away I can write the domain. Oops. Right away I can write x is an element of reals. X can't equal plus or minus 2. I don't know the range yet. Don't care. I'm not going to find it. I'm going to look at this and say, I know the horizontal asymptote. Because this time the powers match. And I think if x goes to infinity, so the limit as x approaches infinity of f of x, again, this is calculus notation, we don't have to have it, but this time it's going to go to 1, right? As the rest that gets big, we drop that away. So I use this right there. And finally, I'll put in the zeros. Zeros occur at 3 and 4, right? How annoying is that? Those are really close together. This graph is going to be very ugly. There they are, 3 and 4. Now I have to make a gigantic sign table. It has 4 factors across the top, right? And it has 4 factors across the top: x minus 3, x minus 4, x minus 2, x plus 2, and it has 4 factors on the side. It has negative 2, 2, 3, 4. Then we'll mock you, all right, on YouTube. All right, so your table better not be wrong. We're going to take a snapshot of it and save some time. But if you're wrong, like I said, we'll mock you. Let's see if he's right. We'll take a snapshot. We'll move it down here. Yeah, hardly any views. I agree. I'm with you there, bud. You guys got to watch more and make more money. All right. All right, so let's see if you did it right. I'm going to check and mark them as I go. So obviously x minus 4 is here. Negative, 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 positive. Yeah, you got that one right. Working down, negative, 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 positive, positive. Yep. Negative, negative, positive. Positive, positive, negative, positive, positive, positive. Yeah, it looks good to me. Someone, oh, yeah, we're getting a nod. So we're good here. I'll erase all those chicken scratches. Because now I'm going to go back up and mark in my table with my gold pen here. So I'm going to go left of negative 2 is positive, so it's up here. Right between negative 2 and 2 is negative, so it's going to be down here between the two vertical asymptotes. And then between 2 and 3, right here is positive, going up towards this asymptote, which I kind of got a little to the left. You see what I mean? So it's kind of hard. Then it hits the 0, then it's negative for ever so little bit of time between those two dots. Right here, right? Negative right there. And then it jumps up and it's positive. It runs to this axis. It's coming back to the asymptote. This is a hard graph to make. I wouldn't hold you to it, but I'd expect you to be able to do this one. That one's pretty easy. So the horizontal and the vertical. And, oh, I should have found the y-intercept way back at the beginning. If I plug in 0 for x, I get 12 over negative 4, I get negative 3. I like having that point. It's negative down there. Now, I have a lot of experience. You guys don't. It's going to just look something like, I would take some sort of parabola shape down there. I happen to know it has a maximum to the right. When I look at this, I can see that these two zeros are going to pull it right. Down here, then, finally, the last thing, it goes through. This is the hard part. It's going to approach this horizontal asymptote right here on the underside. It's hard. And what throws you guys is it crosses it, right? It crosses its horizontal asymptote around the zeros. But I remember what I said about horizontal asymptotes. We don't care around the origin. We don't care around the zeros. This is when x gets really big. Millions and millions, right? We can't ignore minus 7x plus 12 when x is only equal to 3. We can ignore it when it's equal to 3 million. All right? And again, this just takes practice. Lots of rational graphs practice. So what we have on the left, number 1, was a case of no horizontal asymptote. Case on the right, we had a horizontal asymptote equal to 1. And we'll try to work an example where the order on the bottom is bigger tomorrow. Keep practicing.